Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well and your exams are going pretty well. Here we are on the topics of waves, and I think so we had discussed in the previous video regarding what a wave is and the classification one of waves. Waves can be classified into mechanical wave, electromagnetic wave and matter waves. This we have discussed in the previous video. And today we are starting with another classification of wave, in which we have something called as transverse and longitudinal wave. So let's just begin with what do you mean by transverse wave? So when the vibrations of the particles of the medium is in perpendicular direction, note this word, perpendicular direction, to the propagation of wave, then the wave is called as the transverse wave. So when wave is traveling in particular direction, and if the particles are vibrating in perpendicular to the direction of the propagation of wave, then such kind of wave is called as a transverse wave. Like for example, if I have this rigid support and I have taken a rope which has a marking on this particular point. Now if I vibrate the one end, the free end of the rope, there will be a wave going into it. Now if you see this marked point, which I have marked it with a different color, this will go just up and down. So this is vibrating up and down, this is vibrating up and down. However, the wave is moving forward. Now this implies that when the wave is moving in one direction and the particles are vibrating perpendicular to the direction of the propagation, such wave is called as a transverse wave. So the best example would be waves on a rope, or light is also a transverse wave. So light is also one of the best examples of a transverse wave. Then transverse wave travels in the form of crest and troughs. I have just shown you one of the waves. So the upper maximums are called as crest, these are crest, and the lower maximums are called as the troughs. And the distance between a crest and another crest, this distance is what is called as the wavelength. So you denote it by lambda, or you can also say that, like, if this wave was complete till this point, then you can say a distance between a trough and a trough is also called as wavelength. Okay, or you can also say the distance from this particular point to this particular point is also a wavelength. That means a distance between a crest and one trough, one crest and one trough is also called as the wavelength. So I have discussed this point. Transverse wave travels in the form of crest and troughs, and the distance between a crest and the next crest is called as the wavelength. However, you can also modify this to troughs. The distance between a trough and the next trough is also called as a wavelength, or you can say the distance of one crest and one trough is what is called as the wavelength. However, we will define wavelength in coming videos, a very technical definition for wavelength. So this is all about transverse waves, and we'll be discussing about longitudinal waves now. So I have just purposefully written some keywords in orange because the definitions and the points are exactly same, just the orange word is different from what you have learned as of now for the transverse. Like if you see this word perpendicular, that changes to a parallel. Okay, and of course transverse will change to longitudinal, and examples changes. And as so let's see first the definition. When the vibrations of the particles of the medium is in parallel direction to the propagation of the wave, then the wave is called as the longitudinal wave. So you might have seen a tuning fork. A tuning fork, when it vibrates, the air around it vibrates horizontally. Okay, air around it vibrates horizontally. Now when a tuning fork vibrates, when you hit this tuning fork on a rubber pad, and when the prongs of the tuning fork vibrates like this, then what happens is you get portions where the wire is compressed and portions where the wire is not compressed. And where the portion is not compressed, we call it as rarefaction. This is called as a rarefaction. And the portion where the air is compressed is called as a compression. So a longitudinal wave travels in the form of compressions and rarefactions. So if you see, when tuning fork vibrates, if you see one particle, this particle is just going back and forth, and the wave is also traveling in the same direction. So if the particles vibration are in the parallel direction to the propagation of wave, then such a wave is called as a longitudinal wave. So The word parallel is the only difference over here. So sound is one of the best example where sound actually travels in parallel direction to the propagation of wave. The vibrations of the sound is always parallel to the propagation of wave. Then longitudinal wave travels in the form of compression and rarefaction. I have just drawn a longitudinal wave for you. So these are compressions where the lines are very near to each other, and these are rarefactions where the lines are very far away from each other. So compression, rarefaction, compression, rarefaction, and compression. So these are compressions, these are rarefactions. And the last point is, okay, the distance between a compression and the next compression. Like if you start from the starting point of a compression, then take the starting point of the next compression. That will give you the wavelength of a wave. Or you can take from one compression to another compression. Okay, so that also we can take. So compression and rarefaction is the way the longitudinal wave travels. So I hope you have understood this point, and waves can be classified into this transverse and longitudinal as well. But if you can see types of waves: the classification 1, classification 2, mechanical, electromagnetic, matter, and classification 2, it's transverse and longitudinal. We'll also be doing classification 3 as well, but that will be in the following video. Thank you so much for watching, and subscribe the channel in case you have not done so. We will be posting all the entire content slowly and gradually, so keep following the video on a daily basis. Thank you so much. Have a nice day. Bye.